VLSos here. This is a video lesson on converting a quadratic equation into graphing form by using the method of completing the square. I have a quadratic equation in standard form, which is very useful for using the quadratic formula because in standard form I can easily observe the coefficients a, b, and c. Graphing form is a little more useful for graphing quickly because the vertex can be easily seen in the equation. Graphing form is a times x minus h all squared plus k, where the vertex is located at coordinates hk and a is still the coefficient of the x squared term, or the dilation factor. But how can we convert this to be in this form? Notice that graphing form has a square of the x minus h inside of it. So somehow we're going to change this in order to create that kind of square. The beginning, or to start, I'm going to add 15 to both sides, so that I get the two x terms together on one side. And what I'm going to do is strategize, manipulating this or changing it algebraically so that these two terms can turn into x plus something all squared. I want to change the form of this so that it will turn into the kind of square that I'm looking for. How do I do that? Well, I'm going to add something to both sides of the equation, which will help me then complete the square. It's incomplete now because I still have to find that one number that will do that perfectly. As a side problem, what I always need to add to this situation to complete the square, it will always work out that if I take the coefficient b, that which is multiplying the x term, and divide by 2, and then square what I have, I will find that number that will complete the square. In this case, b is equal to negative 2. Because negative 2 is multiplying the x term. If I substitute negative 2 into this expression, I get negative 2 divided by 2 is negative 1, and then negative 1 squared is positive 1. So I have found what to add to both sides. If I add 1 here, then I also need to add 1 to the other side. What I do to one side, I must do to the other. How did that help? Well, I can change this into a square because when I do, I can find now a number to add to x that when all of this is squared will reproduce what I started with. But how do I know what to add here? It's related to finding what I needed to add here. It is half of b, the original b of negative 2. In this case, half of b is negative 1. If I put a negative 1 inside parentheses, then I have completed the binomial that after squaring will produce this. I can check that. X times x is x squared. X times negative 1 and negative 1 times x makes a total of negative 2x's, and negative 1 times negative 1 is equal to positive 1. This is now a square that's been completed. On the other side, I have 1 plus 15 plus y, which is y plus 16. And if I subtracted 16 from both sides, I've completed the graphing form. I'm going to change this plus -1 into -1. In graphing form, I can see that I have an a value, what's being multiplied, or what the x minus 1 squared is multiplying by outside the parentheses must be 1 if I can't see it. And the vertex hk, the coordinates of the vertex, are the h value of 1 and the k value of -16.